Good morning, sir.
Very good morning, madam. How are you all?
I'm fine, sir. Very happy New Year
Happy
to you.
Gudi Parva,
Thank you, sir.
Himanshu.
Thank you.
Happy Gudi server, sir.
Same to you, dear. How are you?
So fine.
Fine.
Yes,
કે
sir.
મજામાં?
So fine.
ગયા અઠવાડિયે એક્ઝામ પતી ગઈ, લેક્ચર અટેન્ડ કરવાનું ચાલુ કરી દીધું, તો હવે તો જલસા જ છે ને. હવે જીવનમાં કશું બાકી છે જ નહીં.
એવું જ છે, sir.
એવું જ છે ને. બાકી બધું તો મિથ્યા જ છે. ચલો. We will wait for 1 more minute and then we are going to start our lecture. Very good morning to all of you students. Dear students, as you all know that in our Saturday's lecture, we have started with 555 timer IC and its application. We have started and discussed the basic configuration, that is the pin configuration of 555 timer, as well as we've also started with 555 timer as a monostable multivibrator circuit. In that circuit, we have discussed what it would be the configuration inside as well as outside in the circuit. We have started discussing in detail about various pin configurations. If I am not wrong, we have already completed the sink and source current. Yes or no? Please respond.
Yes, sir.
So we have to start with pin number 4 if I'm not wrong.
Yes, sir.
Okay. So I request everyone, since we have already drawn the diagram of both the configurations, so please note down about pin number 4. Pin number 4 is a reset pin. I repeat, pin number 4 is a reset pin. In case of 555 timer, it can be used. In case of 555 timer, this pin can be used by applying negative pulse to this pin. By applying negative pulse to this pin. When pin number 4 is not in use, when pin number 4 is not in use, then it is connected to plus VCC. Then it is connected to plus VCC to avoid false triggering. To avoid false triggering. I repeat again. When pin number 4 is not in use, then it is connected with plus VCC to avoid false triggering. Now we move on to the next pin, that is pin number 5. Pin number 5 is a control voltage pin. First point is imposing. I'm extremely sorry. I would speak again. Pin number 5 is a control voltage pin. Is my voice audible?
Yes, sir, audible.
Okay. So by imposing a voltage on this pin or by connecting a potential between this pin and ground pin, The pulse width the pulse width of the output waveform can be varied. Pulse width of the output waveform can be varied. When not in use, the control pin should be bypassed to ground. The control pin should be bypassed to ground with 0.01 microfarad capacitor. With 0.01 microfarad capacitor. Pin number 6 is the threshold pin. Pin number 6 is the threshold pin. It monitors, I repeat, it monitors the voltage across external capacitor. I repeat, pin number 6 is threshold pin, which monitors the voltage across external capacitor. When voltage at this pin is greater than the threshold voltage, bracket 2/3 VCC, output of comparator 1 goes high, which in turn switch the output of timer to low, which in turn switch the output of timer to low. Pin number 7 is discharge pin. Pin number 7 is discharge pin. When output is high, Q1 is off and acts as an open circuit. When output is high, Q1 is off and acts as an open circuit. When output is low, I repeat, when output is low, Q1 is saturated to external capacitor and acts as a short circuit. Now, dear students, I'm going to explain you the operation of 555 timer as a monostable multivibrator. I repeat, the operation, there are 12 steps of operation. The very first step is, I repeat, the very first step is output is low and circuit is in stable state. I repeat, output is low and circuit is in stable state. Can I proceed?
Yes, sir.
Yes, sir.
Q1 is on. Step number 2. Q1 is on and is shorted, and Q1 is on and capacitor C is shorted to ground. Capacitor C is shorted to ground. Third step, applying negative trigger pulse to pin number 2. Applying negative trigger pulse to pin number 2. Step number 4. Q1 is off. Q1 is off, which releases short circuit across C. Which releases short circuit across C. So output is fifth step. So output is high. Fifth step. So output is high. Step number 6. C is charging. Up towards plus VCC. C is charging up towards plus VCC through RA. I repeat, step number 6. C is charging up towards plus VCC through RA. Step number 7. When voltage across capacitor is 2/3 VCC. I repeat, when voltage across capacitor is 2/3 VCC. Step number 8. Comparator 1 output switch from, I repeat, comparator 1 output switch from low to high. It drives, step number 9. It drives the output to its low state. Via output of flip-flop that you have seen in the circuit already. Via the output of flip-flop. Step number 10. At the same time, output of flip-flop turns Q1 on. At the same time, output of flip-flop turns Q1 on. Step number 11. Should I repeat step number 10?
No, sir.
Step number 11. Capacitor C. Capacitor C rapidly discharges through the transmitter. Through the transmitter. Step number 12, that is the last step. Step number 12, output of monostable remains low until
Can you repeat the step 12?
yes, step number 12, output of monostable remains low until a trigger pulse is applied. Cycle repeats itself. Now, for all these principle of operations of 12 steps, there are few important terms. Or rather, there are few important points that are required to be followed strictly. Then and only then we will get the required output. The important terms are number one, pulse width. I repeat, pulse width, width of the trigger input. Must be smaller. Than the expected pulse width. Of output waveform. Second point is trigger pulse must be negative going input with amplitude larger than 1 by 3 VCC. Output remains high for TP is equal to 1.1 RAC seconds.
Sir, can you repeat?
Output remains high for TP is equal to 1.1 RA into C. 1.1 RA into C. Application of 555 timer as a monostable multivibrators are: number one, frequency divider circuit. 555 timer can be used as a monostable multivibrator for frequency divider circuit because it cannot be triggered. It cannot be triggered during the timing cycles. Hence, it is used as an application of 555 timer. I repeat, 555 timer as a monostable multivibrator can be used for frequency divider circuit because it cannot be triggered during the timing cycle. During the timing cycle. So how it is used as a frequency divider? It can be used by adjusting the length of the timing cycle. The length of the timing cycle. It can be used with the help of the timing cycle. If you remember correctly, I have drawn a waveform. If you remember correctly, we have drawn, not I, we have drawn a waveform where in this waveform we have mentioned what is TP. What is TP? So it can be used by adjusting the length of the timing cycle, that is TP with respect to capital T. TP with respect to capital T. This is the capital T whole cycle and this is the peak time. So it can be used as a frequency divider by adjusting the length of TP with respect to T, trigger input signal. Okay. Now, it can be used as a divide by two circuit. Frequency ने divide करवी है ना, so it can be used as a frequency as a dividing by two circuit if we are having the condition TP greater than capital T. If we are having a condition that is TP greater than capital T, and it can be used as dividing by three circuit by having a condition of TP greater than 2T. TP greater than 2T. Okay, this is one of the application. One another application is a pulse stretcher application. Pulse stretcher application. In case of pulse stretcher application, the output pulse width must be larger than the negative pulse of the input signal. Then the negative pulse of the input signal. That is, output pulse width is of stretched version as compared to narrow input pulse. As compared to narrow input pulse, output pulse width is stretched version. It can also be used as an example like LED flashlight or LED driver circuit because it flashes the light with narrow pulse widths. Pulse width ને આપણે control કરીએ તો જે LED નું glow time છે એ as a driver circuit work કરશે. Okay, so this is known as pulse stretching. તમે LED as a જ્યારે તમે first when you were in first year or in 12th standard you were using as a LED driver circuit, flash drivers. Disco light જે આપણે કહીએ છે LED માં, so that is example of pulse stretcher because we are increasing the pulse width of the total cycle. Okay guys, can I proceed further?
Yes, sir.
Yes, sir.
Now I am moving towards 555 timer as a A-stable multivibrator circuit. 555 timer as a A-stable multivibrator circuit. I request everyone to kindly draw the circuit diagram as well as the waveform. Once it is drawn, please let me know so that I can proceed further. Once it is drawn, please let me know so that I can proceed further.
Sir, done.
Okay. Yes, enrollment number 55 completed. Enrollment number 26 completed. 55, 26.
Yes, sir.
Okay. Can I proceed?
Yes, sir.
So guys, according to the given circuit, output is high. C starts charging towards VCC. I repeat, capacitor starts charging towards VCC via RA as well as RB. Via RA and RB. As soon, please note down. Please note down. Number one, when output is high, when output is high, capacitor starts charging towards VCC via RA and RB. Via RA and RB. Point number two, as soon as voltage across C, as soon as voltage across C is to two-third VCC. I repeat, as soon as voltage across C is equal to two-third VCC, 2 by 3 VCC, comparator 1 triggers. Comparator 1 triggers the flip-flop, and output switches to low. And output switches to low. Point number 3. Should I repeat point number 2, Vidisha? Should I repeat? You raised the hand. Please write down in the chat box. Should I repeat, yes or no? Okay. Thank you, Vidisha. Point number 3. Now capacitor starts discharging. Now capacitor starts discharging through RB and Q1. Through RB and Q1. When voltage across C, when voltage across C is equal to 1 by 3 VCC, I repeat, when voltage across C is equal to 1 by 3 VCC, comparator 2 output triggers the flip-flop and output switches to high. Next point, cycle repeats itself. Cycle repeats itself. Time during which time during which capacitor charges from 1 by 3 VCC from 1 by 3 VCC to 2 by 3 VCC is equal to the time during which output is high. During which output is high. And it is given as PC equals to 0.69, PC equals to 0.69 bracket RA plus RB. I repeat, TC is equal to, that is the charging time. TC means the charging time. The charging time is equal to 0.69 bracket RA plus RB bracket closed multiplied by C. Bracket closed multiplied by C. Time during which, next point, time during which capacitor discharges from 2 by 3 VCC to 1 by 3 VCC. From 2 by 3 VCC to 1 by 3 VCC, it is equal to the time, output is low. TD, that is discharging time. I repeat, TD. D is for discharging time. That is equal to 0.69 RB into C. 0.69 RB into C. The two formulas for charging and discharging time that I have dictated to you, you might have written up till now, is having a derivation. That derivation is not the part of the syllabus. कि 0.69 ક્યાંથી આવ્યો છે? That is not the part of the syllabus, but still, if you say yes, then I will upload the required document in your MS Teams. If you say, or if you're not interested, then it's fine, not an issue. Totally depends on you. The application of 555 timer as an astable multivibrator is number one, square wave oscillator circuit. Is number one, square wave oscillator circuit. The second application is the ramp generator circuit. The second application is the ramp generator circuit. For square wave oscillator circuit, this diagram is used. I request everyone to please draw square wave oscillator in the case of 555 timer as an astable multivibrator circuit. That is, the stable state is always switching from one to the another one. There is no stable state for a particular time period. So I request everyone to kindly draw the circuit for square wave oscillator. Once you have drawn, please do let me know so that I can proceed further. હર્ષ જોશી સર્કિટ થઈ ગયો બેટા?
ના સર બાકી છે.
ઓકે કમ્પ્લીટ કરીને મને કહેજે હા.
હા તો સર થઈ ગઈ સર્કિટ.
ઓકે બેટા. Please note down. Duty cycle is of 50%. Duty cycle is of 50%. Now duty cycle 50% છે, that means RA is equal to 0 ohm, which is practically not possible. RA is equal to 0 ohm possible as nothing. The solution is there is a diode across RB. There is a diode across RB. C charges, capacitor C charges via diode, via RA and diode B. Capacitor C charges via RA and diode D. Now, up till what value the capacitor would charge? The capacitor would charge up to 2/3 VCC. The capacitor would charge up to 2/3 VCC. And it would discharge from where? It would discharge from RB and terminal 7. RB and terminal 7. Until what value? Until C reaches 1/3 VCC. Until C reaches 1/3 VCC. And then the cycle would repeat itself. And then the cycle would repeat itself. Capacitor ની maximum limit શું છે ચાર્જિંગ ની 2/3 VCC. Discharging ની minimum limit શું છે 1/3 VCC. અને એના પછી as it is cycle repeat થશે. So that is square wave oscillator. That is the example for square wave oscillator. Should I repeat this point or is it understood?
Understood, sir.
Okay. Now I request everyone to kindly proceed for this diagram of ramp generator. Please draw the diagram and let me know whether you are able to draw it or not. So it is going for information. So it is going to change the shape of the information field. Okay. Dear students, once your diagram is over, please do let me know.
Done, sir.
Okay,
Done,
I
sir.
will just wait. Okay, okay. Now, in this circuit of ramp generator, I hope you all know what is a ramp generator. Ramp generator is basically this kind of output circuit. We're basically having this kind of output circuit. So you are requested to draw the input waveform as well as the output waveform. Input waveform as well as the output waveform. In some of the ALAs that I have given to you, some of the mini projects that I have given to you, I have told you to draw 555 timer as a monostable circuit, as a A-stable circuit. So you need to understand how it is being done and why it is being done. The instructions for those topics are already given to you. You need to upload the PPT on MS Teams. You need to show me the circuit diagram in a working condition in any of the softwares and the output waveforms. Based on that, you need to take the screenshots and attach it in a report form and submit the report on the drive to your experimental batches that you have been allotted with, along with the PPT that you need to upload it on MS Teams. These were the few topics that we have already discussed, and now we are proceeding towards the ramp generator. In a ramp generator, basically RA and RB. I will give you certain time to draw the waveform, then I can proceed. Please draw the output waveform. Once you have drawn, let me know so that I can proceed for its working. Dear students, can I proceed further? Please let me know.
Yes, sir.
Okay. So according to the given circuit of ramp generator, RA and RB are replaced by current mirror. I repeat, RA and RB are replaced by current mirror. It starts charging through C. So the circuit starts getting charged through C towards VCC at a very constant rate. At a very constant rate. C discharges through Q1. I repeat, C discharges through Q1, transistor Q1. This is transistor Q1. So C discharges through Q1, but when the discharge voltage across C, but when the discharge voltage across C reaches one-third VCC, reaches one-third VCC, comparator 2 turns Q1 to off condition. Comparator 2 turns Q1 to off condition. As a result, C again gets starts charging. As a result, C again gets starts charging. The charging time is negligible as compared to discharging time. The time period of ramp is known as charging time. The time period of ramp, as you can see in the waveform, that is known as charging time. So guys, we will start with ELL, phase locked loop, on our Thursday's lecture, in our Thursday's lecture. So till then, that's all from my side. In case of any doubts or queries, please feel free to ask me. I repeat, please feel free to ask me. These topics I am covering from Gaikwad book of Operational Amplifier with Integrated Circuits. That's all from my side, guys. Thank you. You may leave the meeting now.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.